Well, good afternoon, everyone. I hope you're all enjoying lunch, and I'm very happy to be here up on the stage with a distinguished panel to talk about the edge. We have great speakers from Dell, VANTIQ, ClearBlade, SWIM.AI, and I'd first like to start by asking each of you gentlemen to take a minute, briefly introduce yourselves, your organizations, and how that relates to this topic of the edge. Jay, why don't we start with you?
Absolutely. I'm Jay Shaver. I'm Senior Director of Product Management at SWIM.AI. We're an edge software intelligence company based in San Jose, a relatively young startup, been founded for a couple of years. And we've just kind of started going commercial with a couple of different areas in terms of manufacturing, oil and gas, and smart cities is a key area we've had a lot of focus on recently.
Thanks. My name is Neal Kohl. I'm Director of Strategy for our Edge and IoT Solutions Group as part of Dell Technologies. So some of you probably have Dell devices, but when you think about Dell Technologies, I'm actually talking about the whole portfolio of companies that came in with the acquisition of EMC. So we work across our enterprise gear, the EMC portfolio, the team at VMware, some of their IoT portfolio, as well as RSA, SecureWorks. And the goal of our solutions group is actually to bring all those components together into IoT solutions. And look forward to sharing more about that today.
Great. Hey, I'm Eric Simone, founder and CEO of ClearBlade here in Austin, Texas. We are an edge computing company founded in 2007, and we work with companies like Dell, and HP, and others.
It's a big market. It's a big market. We got room for everybody.
And in the vertical space, we're a horizontal technology, but a couple of areas where we're focusing is in transportation and rail, and smart cities in New York.
Thanks, and I'm Blaine. We all chatted a couple times already. One thing you maybe didn't know is I am a Canadian, so as you can see.
I thought they were changing the national plant.
It's nice.
Clapping for Canadians, I like that. That's amazing.
Tim Hortons.
Yeah, it must be Tim Hortons. They love the Tim Hortons coffee.
Aren't they changing the national plant as of this week?
Yes, they are changing the national plant. It looks a lot like the plant behind us. But yeah, we're changing the flag, actually.
The flag, yeah.
But I am an American citizen as well, Mr. Trump, so don't worry, I'm going to be okay.
Is he here?
I don't know. I think he's listening. And the reason VANTIQ is, I think, represented is we talked a little bit about edge computing earlier today, but the platform was architected from the ground up with the notion that if you're going to be involved in IoT and managing all this data and events, you need to be able to be thinking about edge first, because there is no way to put all this data into one central system. You've got to process at least some of it on the edge.
Great, thank you. So the edge can be sometimes a nebulous term, and just to set some context for the audience about what we're up here to discuss today, Eric, can I ask you to start with just maybe defining some terms, some of the permutations of what edge means in the marketplace?
Sure. There's a lot of stuff that gets mixed up. It's early in the market. One of the things I see mostly is the difference between edge network and edge compute. There are vendors out there, I won't name, that will tell you that 5G is going to save the world and it's all going to be able to run on the edge of the cloud, close to an event. I disagree that I think that will help, but you need actual edge computing on the device. I don't think many people will debate that. Think autonomous vehicle. If my child is running in front of that vehicle, that command better be running on the car and not close to the edge, because I don't want to get a free month of AT&T service if my kid gets run over by a car. So in general, I think defining the difference between edge of the network and edge computing is really critical.
Right. Okay. And then in terms of the importance of the edge, what are the benefits of the edge? Why should the CIOs and other end users here care about this topic? Blaine, do you want to start us off with that?
Many. So latency issues are one thing. Back exactly the example you had. When you have to make split-second decisions, you're going to run that as close to the real edge as possible. Reliability is one. So you know, edge computing and edge systems are able to be offline, for example, for certain periods of time. They don't rely on an always-on connection. Bandwidth obviously is one, where if you're able to process data in multiple locations at the same time, you don't need nearly as much bandwidth as if you were all trying to process it at once. And another one that we don't think of too much, but power consumption is also very important. Again, if you can do micro-level processing of smaller amounts of data, you can do it with much less power than if you're trying to have larger systems process a lot of data. So there's a few good reasons.
Great. And I imagine there must be a potential or risk, rather, for fragmentation at the edge, whether in the equipment or in the software. So, Neal, could you walk us through what could be done or what is being done in terms of trying to reduce that risk of fragmentation?
Yeah, so I think the challenge is the fragmentation's there, right? To a large respect, you can't do anything about that fragmentation except think about what's next. And so you see efforts, there are companies building whole business models on letting you connect to some of those legacy devices and get that legacy set of data. And if you like paying, $1,000 per device connector, that's a great business for them. Our view, and what we're big fans of, is promoting openness, promoting standards. Standards take a lot of time, but there's efforts like the EdgeX Foundry is one that we're big proponents of. This was a project that we started internal to Dell. We called it Project Fuse, all about enabling interconnectivity at the edge, making that open source, driving that through APIs. We knew we couldn't scale that up alone, so now it's part of the Linux Foundation. And that is now OEM agnostic, it's OS agnostic, completely vendor agnostic. And part of our role in the solutions group is just evangelizing that, right? Keep the edges open. Make it easy for people to build products that are going to connect. Make it easy for people using those products to get the data out and get it where they want it to be and not where that device vendor wanted it to end up. So great projects like EdgeX out there that I'd suggest you guys look into if you haven't already.
Great, okay. I'd like to spend a few minutes now asking each of you to talk about some project, almost like a case study, some project that you've been involved with, maybe lessons learned, lessons that our audience can draw from. Jay, can I start with you on that?
Yeah, absolutely. So some of y'all probably have already heard some of this, but I'll go ahead and kick it off for those of you that haven't. One of the case studies or the use cases we've been going through is actually with a partner in the traffic space. So they came to us because they had a couple of autonomous vehicle manufacturers and other automobile manufacturers trying to get access to real-time traffic data from various cities. And every time they went to go try and implement something with the cities, it was about pulling the data up. It took a lot of network data storage and a lot of other costs. It didn't make it very effective. And so one of the things they wanted to do is look at how do we take edge compute processing and how do we reduce that data traffic? How do we accelerate how we get access to that data and make it more public APIs? So we've kind of launched that in conjunction with that partner as part of an entire service where you've got access to data on a real-time basis. And when we're talking real-time, we're talking anywhere from about 75 to 150 milliseconds. You can get access to data from a traffic light, which is when you get to that case of a Tesla driving down the road and it needs to have access to real-time data so it doesn't hit a kid crossing the crosswalk. It needs to know, hey, there's a pedestrian crosswalk signal that's been triggered and those types of pieces. So enabling that data is one piece. In terms of the lessons learned and everything, I think they started out with a couple of different challenges in terms of the volume of data. When we look at a lot of the telemetry, and that's essentially what a lot of smart city data is. It's a lot of telemetry that has some redundancy in it. It's zeros and ones that are piping across at a fairly high rate and trying to transmit that and trying to make that accessible. Well, one of the advantages with edge compute is you can do a drastic amount of data reduction on that. The key numbers that I've kind of been throwing out today and talking about is Palo Alto, near where we're located, they've got about 100 intersections. 100 intersections pipes through, and on a daily basis, it's about 4 terabytes of data, 4.32 terabytes of data. By doing edge processing and and data reduction, we've taken that down to about 3.45 gigabytes. So, it's still 3.45 gigabytes. It's still a lot of data, but it's more than 1,000-time reduction of data. And so it makes it much more effective and efficient when you think of network costs and storage costs for trying to pipe that data across. So in terms of In terms of trying to bring relevancy and context to data, it's one of those things that we've learned is they wanted to key in on what's the speed with which we can get data, how do we make it have context and relevance, and how do we do that in a cost-effective way.
Great. Great. Neal?
I'll tell you the moral of the story ahead of time. It's the use case that you end up really loving isn't necessarily the one you start with. So we're working with a Department of Transportation. It's a cold city. Well, I guess here today it's a cold city. But they have snow, and they had snowplows rolling out, dumping salt, and occasionally these guys just wanted to dump their salt somewhere in the woods and take a nap. So we want to do some truck monitoring, right? We want to know where's the truck, how much salt have they spread, what's left in that load. And the other problem that comes up is people like to call them and say, you hit my car, right? So they want to know, did these trucks actually impact anything? Do I have a record of it, or can I show that I didn't have a record of it? So those are kind of the starting use cases around this Department of Transportation project. And then one of the things that got implemented were cameras on all the vehicles, right? So not just the motion, did I bump into somebody, but what am I seeing? What am I looking at on the road? And this is one of the things that they ended up falling in love with, was now they had a fleet of vehicles giving them real-time data about the conditions on the road, what were the problems with traffic. So rather than have these static cameras around town, they had this fleet of cameras that was constantly in motion. And that ended up being the use case that the customer really loved. And then the added benefit of that, the city was hosting a big convention, a big election convention. And they took these same trucks and they were using them for security around the building. And they also became security cameras. So it's just some really neat use cases out there with which to explore, and where you think you're going to find value, in making sure that that job got done correctly, or preventing some liability, may actually end up creating a lot more value by more effectively deploying those resources.
Mm-hmm. Very cool.
Sure. I'm going to choose the New York City project that we're in. Project called Hudson Yards, if you've ever heard of it. It's a $25 billion private real estate project. Little old ClearBlade, who knows very little about building facilities, got selected over Johnson Controls and others, really because of edge compute and because of the openness of our edge compute and the ability to stream. Initially, we're doing HVAC data off Johnson Control chillers in the basement and putting edge compute, I think 5 devices per floor on each high-rise. We're starting with Hudson Yards 10, the first building. And it's really about building connected neighborhoods, more energy efficient neighborhoods, more cost-effective neighborhoods for maintenance and so forth, and safer neighborhoods. So a lot of these things are, the next step we're working on is security cameras for facial recognition and tying in elevators and escalators and all sorts of different things. And it's a combination of servicing the tenants of the building and the community and servicing the maintenance and the safety personnel around it. One key component for Edge is the fact that Hudson Yards does not want any of their data in a centralized cloud because we've had too many data breaches in the past, and New York high-rises need to be safe. And so they want to do all this stuff behind the firewall in their own systems and have distributed data and edge compute where you have to piece this stuff together. So using data and blockchain and some of these things, no one person can get at your data store in one centralized place that's being run by someone else. I think that's really critical.
Interesting.
Can I just pile on for 1 second? I mean, one of the things you said, and I don't know if it's come up much, but this idea of IoT, treating IoT like infrastructure, right? I think you talked about we're starting with this use case. We're going to go build these additional use cases on it. And that is one of the things that I think is taking shape, is people are starting to look at, I'm putting this IoT in not for a project, right? I've got this edge intelligence, I've got this network capability, this storage capability, but because of all the projects that will come, right? So thinking about this from a volume of data standpoint and scalability, thinking about this from the projects that it might have to support in the future, is really where we're headed with this, as opposed to a lot of what we've been doing the last couple of years is let me just go knock out this use case as fast as I can in a POC, and then can I go deploy it somewhere? And so I think that's also an important theme to keep talking about.
I'll add to that and probably make you happy. I'm ex-IBM a couple times. I've seen this movie before, mainframe to PC, if everyone remembers it. I know Dell does. Here we go again. We're going cloud to edge, and it's happening because distributed computing is coming back. And as a computer scientist, one thing I've learned over my 30 years in this business is that pendulum swings from centralized to decentralized or distributed computing, and we're on the swing back. And edge is going to be critical on that.
Absolutely, great examples. How many people in the audience, or has anybody in the audience heard of Tuja? Tuja? What? Yeah, I know you've heard of it, Robert, from VANTIQ. So imagine Airbnb, like we all know, and in fact, many, I'm sure you city people are not super enthusiastic about sometimes. Imagine Airbnb times 5, okay? Because Tuja is the Airbnb of China. And they have millions of homes, apartments, condos under management, and especially, in the Chinese market, I'm sure you've seen the pictures, if not been there. Many of these high-rises are being built like crazy as places to put money, and they're mostly empty. And the people that own these apartment units want to rent them, need to rent them, so they're all on Tuja. It's a massive, huge market, and now a lot of tourists are going to China as well. And they had the original use case, to your point, about putting sensors and using sensor data in all these units in real time to be able to unlock doors when a visitor came to the unit, using electronic locking, using security systems to be able to turn them on and off, measure the physical presence of somebody to help the owners and mainly the guests better access and control access to the building. So connecting that all up using IoT-enabled devices and sensors was the original use case. But then eventually they realized, hey, since especially because these units are empty a lot of the time, let's put a water sensor near the hot water heater, let's put some other temperature sensors, other things in the unit, and then we can sell back to the owners as a service a monitoring capability to make sure their unit is fine, make sure it's working, it's operational, it's not flooding, it's not overheating, whatever the case is. And now they've created, almost by accident, an entirely different line of super high margin revenue generation that wasn't even part of the original mindset because they have this capability, sensors, this data available. And now the reason I'm bringing up this example is, of course, when you have millions of units under management, this has to be run and processed on the edge. In many cases, they're using an edge gateway, a device in the building itself to do the initial processing because they might have 75 units in one building that are empty and under management by Tuja. So it's either a process at the building level or maybe at the neighborhood level, and then only when there's an issue does something actually go to the major application in the cloud.
Interesting. Okay. So mobility and transport is obviously a key application area in the smart city. And Jay and Neal, you've both mentioned ITS-related case studies, as it were. Eric and Blaine, are there areas that are related to mobility, transport, intelligent transportation systems where you've seen this concept of edge have a play?
Yeah, mind if I start? Yeah. One of our other big customers is up in Fort Worth, BNSF Rail. There's anyone heard of the government mandate on positive train control? Really stopping our trains from falling off the tracks and running into things and hurting people. So it's nice when there's the government behind it pushing some of this innovation. But BNSF had a real problem. They've got some older architecture out there around railroad crossings. So they've got some GE compute unit and a 3G communication for really setting up a heartbeat. Are the arms working? Are the lights working, et cetera? But they need to get off 3G because 3G is going away. So they got to roll a truck to 30,000 wayside crossings, which is not a cheap endeavor. So thank goodness they got connected to us. They are rolling some new hardware out on those crossings. We've got 30 in production today. Another 250 in Houston are going out before end of year. And what they're doing is, instead of just setting up a heartbeat, now we've got real-time edge computing running on the crossing. I think we're using a LoRa network now. And that runs autonomous from any connection, like you mentioned earlier. We're doing anomaly analysis, so when something is out of whack, someone's going to get notified. There's doing some machine learning on the edge, so every crossing has its own signature, so in terms of traffic pattern, in terms of rail pattern, in terms of safety. And it's also future-proofing the rollout because you can go over LoRa or say some other protocol so we can push updates down to all of those edge compute devices independently. And I think that's a great use case. Rail, as I've learned, again, we're not rail people any more than we're building people, but we're learning a lot because we're engineering nerds. And so when you put good tools in the hands of people that know their business, then they can proliferate their solutions. But rail is a really technical business, and there's a lot of legacy stuff out there. And I think that's going to be a big factor in some of the IoT growth that we're seeing. Transportation and logistics, I think, are going to be huge.
Okay.
I think future-proofing is a good point. I think Gartner has another stat out saying that by 80% of the edge implementations that are going to be put in place by 2020 will be replaced by 2022, right, fundamentally. Because the technology is moving so quickly, the ability to process and make intelligent decisions on the edge. In many cases these days, it's the cameras themselves that have compute capability in the machine learning capacity. Some of our clients, again, in Japan, I think Panasonic, in fact, is literally doing the initial facial recognition, running those matching algorithms in the camera effectively, and then only sending the data out if the camera knows that it's learned of a situation that's bad. So that's moving, that's moving so quickly. But back to the original question, those that sat in the workshops know that we're working on a number of transportation projects, and they all involve edge computing because a lot of data moving around with analyzing real-time video streams, and basically, fundamentally, the use cases around understanding traffic control, traffic patterns, and ensuring that you're rerouting, in the original use case, city vehicles to keep them from wasting time in waiting states while roads, especially alleyways in cities, are blocked. So a pretty obvious use case, I think, relatively small, but could only happen if you were doing some level of edge computing.
Okay. So Eric, you mentioned LoRa, which for our audience is an unlicensed spectrum band, low power wide area technology. That brings up the question or the idea of how does edge sort of intersect with the various connectivity technologies that cities are or might deploy as part of their solutions?
Well, definitely you're going to have to work over any protocol that's out there, right? Whether it's LoRa or some of the Zigbee, Thread, Bluetooth. I mean, you can go on and on about Sigfox. Well, maybe. We'll see what happens with Sigfox. Sigfox Europe, maybe not. I've got friends at Sigfox. But not to NB-IoT. There's all these different protocols, and this is part of that. Everyone talks about standardization, and there has to be. I like what EdgeX is doing. We're one of the founding members, so we believe in openness as well. And standards like that are going to be critical. And then as these things are going to change constantly. We're going to go from LoRa to Wendy. I don't know what's going to be next, right? But we've got to have software that's able to adapt and able to not lock you in and not be custom build on the edge per solution. I mean, I think there's a lot of folks out there today talking edge compute, and it's real custom build specific stuff. We have to get to some standard way of replicating what I call a system or a solution between edge and cloud and on-prem, and do that in a consistent way. And then have this idea of like a container of a system that can then be somewhat hardware agnostic and processor agnostic, and then let the hardware vendors distinguish themselves based on processor speed and service and all these things, and let the software vendors distinguish themselves by standardization, openness, and community. So I think that's what's going to happen over the next decade plus, and it's an exciting time to be in this space. I'm trying to get my kids to go to school and get a computer science degree. They'll be good.
Cool. Did anyone else want to chime in on that particular topic?
I did just a little in terms of when we think about edge, we're not necessarily always relying on on connectivity with the cloud. And I think a lot of devices, you think of connectivity with the cloud, and they're reliant on that. I was telling somebody the other day, I'm based in the Bay Area, was in San Francisco in the city, tried to pull up where's the nearest Starbucks, because I couldn't remember where it was off the train station, and it says I'm standing right in front of it because it has my position 2 blocks down and on the opposite side of the street. Because when you have devices that all intending to be cloud native and all relying on that connection to the cloud, they don't produce accurate results there on the edge. So one of the things that we always keep in mind, and we've got a couple other use cases, not so much in the smart city space, where we're relying on we are expecting that we're not going to have connectivity all the time. And so I think when you think of edge, if it relates to anything that is critical infrastructure, it's safety related, it has a couple of those key tenets and those hallmarks, you've got to think of what if that connection goes down, what is the expected logic of the data and so forth that's going to happen on the edge. I think utilities and in terms of smart grid have made a lot of strides in that case in particular, and there's some lessons learned there. But thinking about edge is thinking about what happens when that connection isn't available and isn't there. What is this device going to do? What's the expected behavior? Certainly, what's the safe behavior?
Right. Okay.
Anybody else?
Well, I just have to imagine that many folks in the audience are thinking, oh my goodness, I'm just trying to get interesting applications in the cloud, and now I've got to worry about all the stuff running on the edge and all these devices and protocols, forget it, right? It's too much. And I think our challenge as vendors actually is to help you abstract away that complexity. So yes, you have to be able to run and do all this machine learning and all this amazing stuff we're talking about on the edge, but without actually having to focus on the complexity. Let the technology abstract away the complexity so you can think at a higher level, but then have, fundamentally run very complex systems. And the good news is I think we're finally getting to the point where where technologies are enabling that to happen. Otherwise, it's hopeless. It's too complicated, right?
Why software exists.
Yeah.
Otherwise, we'd be out of jobs. So.
Okay, so in the 3 minutes and 28 seconds that we have left, are there any questions from the audience? Yes.
So some of the things that we're hearing just in talking with vendors, and we haven't talked about, so I want to get your perspective. As we're doing more on the edge, right, at the device level, what about security at the edge? Can you talk about some of the progression of the chipsets and some of the technology within the devices that are really helping solve the issue that I know that someone mentioned earlier today about the device level security and the risk there as we connect more things? Can you talk about that?
So for the hardware guy.
We're all looking at you.
Yeah. So there's the stack of security, particularly around IoT, is big and complex, right? But it does start with, can we build a hardware level root of trust? And so at least on our the gateways that Dell produces, we use what's called a trusted platform module, a TPM, the same that you would find in your PC, and it authenticates, right? The minute that thing starts to boot, it says, I am who I say I am, I'm doing what I'm supposed to be doing. And so that's a very secure way, but that's also at the gateway level, not necessarily all the way down to the sensor. Thinking about that level, now we've got power issues, performance or compute issues. One of the projects that we have coming out of RSA is a project that's doing behavioral analytics. So just like we might do behavioral analytics, say, on bank employees and say, what's that person doing online at 3 in the morning downloading that big bank of customer data? Well, is that sensor behaving as it should, right? And if the sensor starts behaving oddly, and we can either shut it down, we can section it off, we can treat that anomaly, right? And then it just it continues, like, you have to think about that through the network layer, and ultimately, from the value of like the data that's being produced and where that data ends up, can I trust that data, right? That's ultimately what we care about, what we want to know. So thinking about that full stack is something that's critical, and that starts to bring into other technologies like blockchain that have come up before. I'll mention too, there's another product that we have in the family out of VMware. It's called Pulse. You guys familiar with AirWatch, mobile device management, right? Pulse is IoT device management. So it's thinking about doing AirWatch at that scale of millions. Is that device online? What is it? What's it doing? Is it updated with all the the latest patches that should have gone out to it? Does it have the latest security updates? So just being able to understand what's on your network, what are they doing, are they current? That's a big step towards having a better sense of security.
Yeah, and I'll add to that. Security is a multi-level concern. So you got to work with the hardware, you got to work with the network, you got to work with the application layer. So we all have to do our part, and then we all have to work with what's there, and it's going to be constantly changing, so you have to be adaptable to the threats that come at you. So Dell's doing a bunch of work in this space, and we've actually worked with Dell as well on that front, as well as others.
Okay, we have maybe time for one more question. Sure.
So my question goes around the life cycle for all these edge devices. In Portland, we have right now a number of traffic monitoring modules on our lighting posts, right? And as we are actually upgrading firmware, we're actually realizing that the newer generation of firmware requires a higher degree of hardware that we don't have on site. And it's really expensive to do anything in public areas. It's just the number of contractors, permits, and so on is just, it can kill projects. So that's one concern in terms of making strategic investments, considering life cycle. And the other thing is that as we see all these devices populating everywhere in the city, we are very concerned around electronic waste, basically. Having materials, dangerous materials in our trash cans and everything, right? So those two, in terms of the life cycle for those devices, are main concerns for us. I don't know if you have any comments.
One quick thought is, thank goodness software is eating the world, because if this was all embedded logic in hardware, then every time you wanted to make an update or enhancement, you would have to throw it all out, right? But we're not, we're now moving to the world of not generic hardware, very high-powered, capable stuff that Dell is making and others, but can you can change the software quite easily and quickly. Mm-hmm. The other thing, I know there's a lot of answers in there, but one of the things we've had to do is we have, the server edition of VANTIQ, then we have the Edge edition, which runs, in fact, on Dell, which we're running on Dell gateways, and then we have the Micro edition, which is a set of open source C libraries that you can build applications for on the smallest, dumbest devices, set-top boxes, low-power Raspberry Pi devices, and so you have to be able to have a solution that can scale down to even the dumbest of compute devices.
And kind of tying on to what Blaine's saying, having firmware that you can push out to devices. If you have devices that are in the lights, maybe it's not a solution of updating every one of those devices, but maybe you have an edge compute device nearby that's communicating with a group of lights, and then you can update that and aggregate that communication. So there's lots of ways to design this stuff, and so while the future's exciting, it's going to be extremely challenging on all these levels. But that specific use case, I'd say you'd want to try to find a way to leverage the hardware that you have on the lights, and then maybe leverage hardware elsewhere and software to be able to then get the capabilities that you need. Maybe that's not true edge or close to edge. I mean, that's where, and maybe the edge network then comes into play that we talked about earlier from AT&T and others.
As I was going to say something very similar about kind of putting another layer in there where you can get a little more compute close to the edge, close to those devices. The other thing, I brought up earlier that we have to start thinking about this like infrastructure that we're going to build lots of projects on in the future. And we've had quite a few customers that, through a POC phase, they're like, give me that cheap thing. I want to get started. And then as soon as they get that out there, they realize, you know what, I really want a little bit more. So kind of plan for that you're going to need that capacity. You're going to want some overhead space. Because that first project is not going to be the end of it, right? Or the applications are going to become more demanding over time.
I think just to pile on to some of the things that have been said already, you've got Moore's Law kind of favoring you here in terms of more compute and storage, all those things, the cost of it is coming down drastically. And so it kind of favors more of leaning towards the edge. Like you're talking about not just the software eating the edge, but kind of everything moving from cloud-based and it going back to being distributed and edge compute. Even the software is getting much more efficient. So right now, maybe a heavyweight infrastructure or firmware update, but a lot of the software that's coming out now is actually very much streamlined and being automated in a way that you're going to be able to do even more stuff with the devices and the hardware and the compute power that you've got existing on the edge. A lot of people don't realize this, but even Apple's incorporating this. If you got the latest version of iOS 12, it actually runs faster and more efficient than the previous version, which is kind of the opposite of what normally happens with your smartphones. But people are getting attuned to let's make this more, let's start putting the efficiency down into the device on the edge, and let's start freeing up the compute and the availability for more complex things like augmented reality or those types of solutions. So I think you'll see that transition in the software space soon.
Great. Well, we are unfortunately out of time, but please join me in thanking our panelists.